In this video, we're going to take a look at some special cases when we're solving equations. Sometimes the variables disappear altogether, or sometimes we get some nonsense sentences or comparisons. So let's take a look at our first case. We have 2x plus 6 equals 2, parentheses, x plus 3. So in our previous videos, we talked about how we would solve these multi-step equations. We said we'd start by maybe drawing a line down the equal sign to show left side and right side. Then we take a look at the left side and we look to see if there's parentheses for distributing or if we have multiple variables that we can combine. In this case, we don't, so let's move on to the right side. In the right side, we do have parentheses, so we're going to go ahead and do the distributive property. That means we take the 2 from the outside and multiply it by everything on the inside. So 2 times x is 2x. Bring down your plus sign. 2 times 3 is 6. I'm going to rewrite the left side as well. In our previous video, we also said then because we have variables on both sides, we need to combine them. And our process is to move the variables from the right side over to the left side. You could do it either way. You could move the variables from the left to the right, but I want to show for consistency's sake the same process. So I'm going to go ahead and take my 2x from the right side and move it to the left side. In order to do that, I have to get rid of it. I have to do its opposite. So the opposite of positive 2x is to minus 2x. And I'm going to do that on both sides of my equation, lining up my variables. So I have 2x minus 2x, that's 0. I don't even have to write it, actually. I'm not going to write that. It is 0. I do have a 6 left over on that right side. On the left side, same thing happens. 2x minus 2x is 0. Again, we don't need to write that, but we are going to finish it off, and we get 6 equals 6. I get a true statement. 6 equals 6. That is true, but what happened? What happened? When we went ahead and combined our like terms and moved our variables from the left side to the right side, oh no. What happened was my variables disappeared. If your variables disappear in your process, that's okay, but you want to look at your final statement. I have 6 equals 6. This is a true statement. My variables disappeared, and what that means is that all real numbers are possible solutions. Any number that I can think of could be a solution to my equation. So it says sometimes every x that will make the equation true. And we can test out a whole bunch of them. But what that means is our answer is all real numbers. Any number we can think of is a solution. This is what happens when our variable disappears and we get a true statement at the end. So we're going to just test out a couple. So again, if we were solving this, yes, we get a true statement. What do I write down as my answer? My answer is all real numbers. Not true, but all real numbers. And in order to prove that, we can verify. We get to just pick whatever x values we want. So I'm going to pick some easy ones. I'm going to pick 0 and plug it in. So let's see what happens when we plug in 0. We've got 2 plug in 0 plus 6 should equal 2. Again, plug in 0 plus 3. So that's what I'm working with. So 2 times 0 is 0 plus 6. That's just 6. On the other side, 0 plus 3 is 3. So I've got 2 times 3, and that is also 6. So that worked. What if we plug in 4? Let's plug in 4 instead. Let's plug in 4 and see what happens. So I'm just putting it in a big bracket so I can see my equation, but I'm going to go ahead and plug in 4. And I'm going to get a completely different answer here. Let's see, 2 times 4 is 8, plus 6 is 14. Working my parentheses, that's 7. 2 times 7 is 14. See how I'm getting a different answer when I verify? But I'm getting a true statement, just like I did over here. So our answer is all real numbers because we can pick any number we want, plug it in, and we're going to get a balance. The left side will equal the right side. So again, if that's true, our variable disappeared, we get a true statement. Our answer that we should write down or fill in or select if it's multiple choice is all real numbers. Let's take a look at a different case. So let me hide that for just a second. Let's see. In this special case, again, we're going to go ahead and draw our line down the equal sign. Look at the left side. Do I have anything to distribute or combine? No, I just have 3x. Look at the right side. I do have parentheses, so I'm going to go ahead and distribute. 3 times 4 is 12. No, it's not. What am I doing? 3 times x. Woo! 3 times x is just 3x. Then we have 3 times 4 is 12. You might be able to look at this and already see, like, all right, if one side's 3x and the other side's 3x plus 12, it's not going to be balanced, but we're going to keep working our process. So here I move my variables from the right side to the left side. 3x minus 3x is 0. 3x minus 3x is 0, but I still have the 12. All right, let's take a look. It says 0 equals 12. Is that true? Does 0 equal 12? No, that's false. So my variables disappeared and I got this kind of nonsense answer, 0 equals 12. That's not true. Let me put a little slash through that equal sign. So if that happens, my variables disappear. That means I have no solution. And that's my final answer. That's what you would select. That's what you would type in. That's what you would select if it was multiple choice. No solution. What we're saying here is that there's nothing that we could plug into x that's going to give you a balance of equation on the left and the right side. And you could try. You could plug in 0. You're not going to get a balance. You could plug in 2. You can plug in negative numbers. It won't matter. What happens here is our x disappeared, and we are left with a false statement. 0 equals 12. That is false. So what's our final answer? No solution. So to repeat, we had 2 different special cases. One case, our variable disappeared, and we ended up with a true statement. 6 equaled 6. That was this one. So we say, all real numbers is our answer. Our second special case is when our variables disappeared and we got a false solution. We say no solution. There's one more thing we want to review, and that's when we have an equation that looks like 2 fractions set equal to each other. This is really like a proportion, and you may be unfamiliar with how to solve this. So in order to do this, we're going to do something called cross multiplication or cross multiply. And what that is really multiplying across the diagonal. So some of us like to circle the diagonals to show what it is we're multiplying. So if I were to multiply across the diagonal, I'm going to do 4 times 3. That's 12. That goes on one side of my equal sign. And on the other side, I have 2 times x. Well, that goes over here. Now I have a one-step equation that I'm used to seeing. So I'm going to go ahead and just continue, which is means divide by 2. And we get x equals 6. We can go ahead and verify this like we've verified other equations by plugging in our 6 to our fraction. And what we can do is, again, cross multiply. 6 times 2 is 12. 4 times 3 is 12. You could divide your fractions, both sides. You'll get 1.5 if I'm looking at decimals here, 1.5. You could verify it a couple of different ways, but this worked out. I might have something a little more complicated. Look at this next one. I have x plus 1 in the denominator of my first fraction. That is the entire quantity there. Oh, I said the special word. I said quantity. What does that mean? Well, when we were translating, quantity meant parentheses. So I would like, if you ever see what's called a binomial, x plus 1 or 7x minus 2, something that has, it's more than just one variable or one number, you can put parentheses around that. And I hope that rings a bell or triggers something in you that you have to distribute when you cross multiply. So let's take a look. We are going to multiply this diagonal, and that's just going to be 3x. Nothing special, nothing complicated there. On the other side, what I really have is 2 times this quantity, x plus 1. I shouldn't just do 2 times x and then plus 1. I have to make the 2 multiply the entire thing. So that means I'm distributing. So that becomes 2x plus 2. And this is where, right here, that 2, that second set of the distribution is where I see most students make a mistake. So if you can, I'd maybe put a little star on this one, come back to it, review it, look at your steps, and make sure you understand what's going on. If we finish off the problem, I'm going to go ahead and move my variables from the right side to the left side. So I'm going to subtract 2x, and I'll get 1x equals 2. And I don't actually need to write the 1 in front of the x, it's implied, but if you're not sure, you can go ahead and divide by 1 on both sides, and you'll get x equals 2. Now for a problem like this with that quantity, whether it's in the denominator or the numerator or both sides or in multiple places, I definitely want to check and verify. So we're going to take 2 and plug it in. I've got 2 over 2 plus 1 equals 2 over 3. So if I check, I'm going to simplify my fractions. I've got 2 over 2 plus 1 is 3 equals 2 over 3. Without dividing or cross multiplying, I can see that these two fractions are the same. So my solution is correct. Again, this is cross products, multiplying across the diagonal. Please make sure you show steps, because once you multiply across the diagonal, you want to set them equal to each other. Each diagonal, each product from your diagonal gets set equal to each other. You have some to try on your notes. Solve the equation if possible. If it's not possible, you're going to get a solution like all real numbers or no solution. And then you do have to verify your solutions. It does say for the first 2 rows, justify steps. That's just using your addition property of equality, subtraction property of equality, multiplication property of equality, or division property of equality. You might also want to write distributive property if that's something you were doing. Go ahead and pause your video and take some time to practice these problems, and we'll put the answers up in just a minute. Okay, take a look at your answers. For letter A, we're just moving our variables from the right side to the left side and then solving a 2-step equation. We get x equals -2. Same thing for letter B. Be very careful with your integers. Use your calculator to help you with those coefficients. But again, we're moving variables from the right to the left. Solving a 2-step, we get x equals 1. On letter C, we had distribution on the right side. Again, combining variables, solving a 1-step equation, x equals 8. Letter D, we had distribution and variables on both sides, x equals 5. For letter E, we went ahead and distributed on the right side, got a false statement. Our answer is no solution. Make sure you know your answer is no solution. And for letter F, again, we distributed. We had the same thing on both sides. So when we solved it, our variables disappeared. We got a true statement, all real numbers. Here are the answers for the last 6 problems. 7, -.